Awesome, we're good. Oh, you're on mute, Rob. Or I don't hear you. Zoom. Are you there? Oh no.
Can you hear me now?
I can hear you now. Yes. Much better.
Awesome.
Sweet.
Win for technology. Welcome everyone to Boston Azure. I'm really excited to present today choosing from the many ways to Docker in Azure. We're going to look through a lot of different compute mechanisms inside of Azure and see how we can host containers there. Here's the part where I tell you I am definitely going to post the slides on my site tonight. Have you ever heard that from a speaker and you're just like, but are you going to post them? Which is why I've already tweeted the link to the slides, and let's head over to robrich.org right now. We'll go to robrich.org, and here's, click on presentations here at the top. Here's choosing from the many ways to Docker in Azure, and the slides are online right now. Woo-hoo! Achievement unlocked. So while we're here on robrich.org, let's go click on About Me, and we'll see some of the things that I've done recently. I'm a Microsoft MVP and MCT. That was a lot of fun. I'm also a Docker captain, a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here in Boston or wherever you're watching this video from, hit me up on email or Twitter or find me here at the meetup. And let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, Pro Microservices in .NET 6. That was a lot of fun. I got to work with Sean and Matt on that book. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air and they sent me a mug. Woo! And if you'd like to, no, I'm just kidding. So that's some of the things about me. Let's dig into some of the things about Azure. So there's lots of different ways that you can run containers in Azure. Azure Kubernetes Service, Azure Container Service, Azure Container Instance, Azure Service Fabric, Azure Web Apps, Azure Container Apps, Azure Container Registry. And it's like, which one should I choose? I'm going to frame that a little bit differently and talk about when should I choose each one. Let's take a look at each one and see how that works and when we might choose each one and what makes that one superior in that use case. Taking a step back, what is Docker? Well, Docker is container virtualization. What are containers? They're lightweight kernel virtualization. Unlike typical virtualization with like Hyper-V or Xen or Parallels, we're not virtualizing the hardware, we're virtualizing the operating system. And so then Docker is this suite of command line tools for building and running these container images. Now that's kind of cool. We're virtualizing the operating system instead of the hardware, which means here on the left is traditional virtualization, on the right is containers. We can see that we're already using the content much more efficiently. On the left, we only get 3 virtual machines, and on the right, we got 7 containers. Now, this is definitely not to scale, but we can see we're already using our hardware more efficiently because we don't need these duplicate copies of the operating system in each container. Each container is only the difference between the host and what we need to run our application. So this is how we do containers. The cool but annoying part is that because we're virtualizing the kernel, the operating system, our kernel needs to match the kernel in the host needs to match the kernel in the guest. So if we have a Linux container, we need a Linux host. And if we have a Windows container, we need a Windows server host. Well, what's missing? Well, how about GNOME and KDE? How about Windows Desktop? How about Mac OS? Hey, I'm running Docker on my Windows desktop or on my Mac laptop. You telling me that's a lie? Well, yeah, kind of. In production, we want to do it here on the right, where we're using our hardware as efficiently as we can. But on the left is how we'll do it in development. So I'm going to take my Windows laptop or my Mac laptop. I'm going to install my host OS, so Windows desktop or Mac OS. I'll install my hypervisor. In the case of Windows, it's Hyper-V. In the case of Mac, it's HyperKit. And then I'll install a guest operating system. Now, this is a Linux operating system, a Linux virtual machine. And inside that Linux virtual machine, we'll install Docker Desktop. So yes, I have two hypervisors now, but now I'm able to run my Linux containers in my Linux virtual machine on my Mac or Windows desktop. In production, we definitely want to do it this way. We want to do it as efficiently as possible. But in development, we can do it like this. Now, what's really cool with Windows is that this guest OS can be WSL. So if I have WSL2 installed and I install Docker Desktop will notice and just say, hey, can I hook into WSL2? We click yes, everything's fine. Now, the cool part there is that we can pretend that this hypervisor is actually hooked to our host OS. So we can do things like localhost and the port of the container, and it will just map us in automatically. That's really cool. If we're using something like Minikube or Mac OS or some other operating systems and we don't have that WSL integration, then that auto magic proxying between the things is a little bit harder. So that's containers. Let's talk about what is an orchestrator. Now, when we're building these container images, we're getting all of our content into place, but then we need to be able to run them at scale. Now, if I just said Docker run, I've got it running, but I'm only running one of them. What happens if it crashes? What happens if it's not working? What happens if I need to scale up because I'm getting more traffic? That's where we get an orchestrator. An orchestrator is a cluster of machines. We'll take a collection of machines, we'll connect them together, and we'll install the orchestrator on that set of machines. And then we'll give the orchestrator some instructions. Now, we can give it our desired state. I want 3 copies of my application running. I want them across availability zones. I want to be able to scale traffic up and down. I want to have the storage move over here. These are things that we can give to our orchestrator, that desired state. Now in Windows, we have desired state configuration. This is not that. Rather, we're telling the orchestrator our end goal. And however the orchestrator needs to do it, it can do that. So do I put the container here or do I put it over there? If this hardware is having difficulties, I'll just shuffle them all over onto this one. These are things that our orchestrators do automatically, and we can sleep through it. That's really cool. We hand the desired state to our orchestrator, and our orchestrator makes the decisions about which machine should be doing what, and we don't need to worry about it. So, for example, we might hand our orchestrator instructions like, I would like you to start this group of containers. I would like them to be across availability zones. I would like them to cap out at this much memory, this much CPU. If they go over that, consider them unhealthy. If they don't respond to a ping in this way, consider them unhealthy. Or maybe if they don't respond to this web URL, consider them unhealthy. If they're unhealthy, automatically kick them off and create a new one. And so, I don't need to worry about, did that container go awry? The orchestrator is just going to fling it off and pick up a new one. With an orchestration engine, often we'll also have load balancing and a management UI. And so that allows us to visualize what the cluster is doing. So as we pick an orchestration engine, so the TLDR there, an orchestration engine is both scheduling the stuff, but also keeping the containers healthy. Not necessarily that it's going to make our containers work better, but rather it's going to monitor them, and if they are unhealthy, it will start up a new one. So we have lots of different orchestrators that we can choose from: Kubernetes, Mesos, Docker Swarm, Azure Service Fabric, Amazon Fargate. Each of these are orchestrators where we can give them those instructions. I'd like you to run my image. I'd like this many copies. I would like you to keep them running across availability zones. I'd like you to scale up and down using these rules. And each of these can do that. The cool part is that that orchestrator is kind of what we're picking as we pick the various compute pieces inside of Azure. But taking a step back, let's take a look at the Docker ecosystem. They all run containers. Now, so far, I've been using the term container to mean both container and image. I'm going to stop doing that. Let's talk about the Docker ecosystem. We start with a Docker file. And this Docker file is the configuration as code that gives us the instructions of how we build an image. That image is the binary blob that tells us how we might run this, but it's not running yet. Then when we instantiate it, when we start it, then we get a container. So we could think of this like a class file, a DLL, and running the DLL on the server. Or a class file, an object definition, and an instance of the object. Here, when we get to a container, we run it on a hypervisor. In this case, I chose Docker Machine, but we could also choose Kubernetes or AWS Fargate. We just plug in Ethernet and power, and that image spins up as a container. It gets a unique host name and IP address, and is nicely sandboxed from other things. What's interesting is we can choose to share images or download images from Docker Hub. Now, unlike GitHub, where we share our source code, with Docker Hub, we share our binary blobs. So if I download something from Docker Hub, I don't need to recompile it. I only need to start it. That's brilliant. Simultaneously, we could use a Docker Compose file or Kubernetes YAML files to specify many Docker files or many images from Docker Hub or another registry. We now can collect those images and then start them together on a Docker hypervisor like Kubernetes, or in this case, I chose Docker Swarm. Plug in Ethernet, plug in power, identify how these things connect, and I can now run a fleet of services all together on a Kubernetes hypervisor or Docker hypervisor. So that's really cool. This configuration as code is really tiny. It gets us to an image that we can start as a container, and then we can start to run our app really, really easily. If our app has problems, we can start up another container. This image is isomorphic. It doesn't change. So let's go build a container. Now I have here an empty directory. Now we could definitely go into Visual Studio and create an application. That would be fun. But I'm going to say .NET New, and that will allow us to scaffold out a website as well. So we can choose various types of apps. And so I'm going to say .NET New MVC. I'll give it a name of site and an output of dot. Now I could have both name and output are optional. If I didn't specify a name, it would use my folder name. So in this case, demo. And if I didn't specify output, it would create a new folder inside this folder. So then I would have a demo folder, and inside that a demo folder, and my content would be there. So here's our website. If we say .NET Run, then our website will start up. If we say .NET Build, then our website will end up in the bin folder, and we can say .NET site.dll inside that bin folder and launch our app that way. But let's open this up in VS Code and start to containerize it. Ooh, I've got a lot of stuff open. Let's close these because none of those files exist. Okay, so I have my regular website. Here's my home controller, and my home controller has various actions. In this case, here's index. I can come over to my home view, and it says home page, welcome. That's cool. It's a regular website. Now, our first step in containerizing our application is actually to create a .gitignore file. File.gitignore. Now, our gitignore file is everything that we don't want to commit to source control. So we don't want to commit built files. We don't want to commit downloaded files. We don't want to commit user specific files. We don't want to commit temp files. And we don't want to commit secrets. So let's do that. With built files, we don't want to commit our obj folder and our bin folder. Downloaded files. If we were in a .NET Framework app, we wouldn't want to commit our packages folder. Here in .NET Core, or in this case .NET 6, then we, oh, actually, I was supposed to click yes there. It would create a .vs code folder there. In .NET 6, we don't have a packages folder, so there aren't any downloaded files. If we wanted to get really particular, we could go after these libraries here and switch them over to CDN resources and then exclude those. But in this case, I'm going to leave that blank. User-specific files, star.user, the .vs folder, maybe the .vs code folder if we have unique things there, or that's generally, just static stuff that we've created that allows us to debug. So I'll check that in. We also don't want to commit the star.suo, and those are the user-specific files. Temp files. So we might have star.orig, that's created by Git when we do a merge conflict. We might have star.tmp or star.log, any other temp things. And then towards secrets. Right now in our app settings, we don't have any content, but if we chose to put secrets in our app.development.json, we might want to exclude this. Or what I like to do is I come into my app settings and I will say, let's create a connection strings section, my DB, and I will say use user secrets. And now this is the only reference to that. And so inside Visual Studio, I can right click on the solution. I can say use user secrets, which of course doesn't work in VS Code. And so then that secret would not end up in source control and not in development. Or maybe I might put a default here that specifies your local machine, but I'm definitely not going to put any passwords there. So thus far, we've gotten secrets outside of our build just by using user secrets. The cool thing about user secrets is it actually puts the file in my user directory inside app data. And so that's definitely far away from my source control, so I won't end up accidentally committing it. So those are the things that I want to exclude from my Git repository. Any questions so far on these on this git ignore file?
No questions out there.
Cool. So our next step in containerizing this application is to create a .docker ignore file. And so let's call this .docker ignore. And inside this docker ignore file is everything that we don't want in our production container. And it actually has the exact same syntax as our git ignore file. So let's just go grab that and put it here. Now there's one more section that we want to add, and it is non-production stuff. We still want to exclude built files, downloaded files, user-specific files, temp files, and secrets, but then we also want to exclude non-production stuff. So app settings.development.json, and here in properties, launch settings.json. Now, the interesting thing about launch settings.json, this is all of the stuff that we need to be able to debug our app. Here's our development environment variables, the URLs that we'll use both with Kestrel and with IS Express settings. Yeah, we definitely don't want that in our production container. So let's exclude that. And now we've got a .docker ignore file. This is everything we don't want to get copied into our container. Next, we want to create a Docker file. Now, the interesting thing is this is Docker file, not dockerfile.txt. So if you accidentally created this, and the interesting thing is if you create a file in Visual Studio, it'll add the .txt. Easy enough, pull the txt off and just call it Docker file. Here in this Docker file is our configuration as code, our instructions of how to build up this image. So we have a bunch of keywords here. We'll have from, copy, run, and cmd. Now, all of these commands will run as we build up our image. This command is the command that it will start when it launches our container. So we'll only have one cmd command, but we may have lots of these other lines to be able to define what we're building on top of, what we want to copy from, and the commands that we want to run as if they were shell commands run as we build up this image. So we want to start on the shoulders of giants. So let's head over to Docker Hub and we'll search for .NET. And we'll get in this list the .NET repository. Oh, it really wants me to log in. And here's all of the repositories associated with .NET. .NET Samples is fun. It shows us lots of different kinds of Docker files. Monitor is a great way to be able to view ASP.NET apps. Runtime deps is what we would need installed inside of Linux to install .NET, but it does not have .NET installed on it yet. Built on top of that is runtime, which allows us to use console applications, but not web servers. Built on top of that is ASP.NET, which allows us to launch web servers, but it doesn't allow us to compile. Built on top of that is the SDK, which does allow us to compile. So let's pop open this repo and take a look at what we need to do here. Pardon me. Here on the right, this is the base image that we want to pull. So let's come back in our Docker file and we'll do that. We don't need the Docker pull part though. And now let's pick a version. By default, we probably want to use 6.0, but scrolling down a little bit, we can see the other versions available, the other labels. Here's 6.0. If we didn't specify one, we would get latest, which is the same thing. And this is built on top of Debian. There's also Alpine, and Alpine is known for being a really, really small Linux distribution. So let's use the version 6.0-Alpine instead of just latest or 6.0. Now I've matched this 6.0 to the site.csproj 6.0, so I know I'm building in the correct version of .NET. And now I've got the build tools. So now let's copy everything from our directory where we'll run the docker build command to the directory that we've specified in our image. Well, what is that directory? Let's set it. workdir/src. Now I could definitely say var lib foo bar and would automatically create and then cd into that directory. But src works. It's going to copy everything from here except for everything that we chose to ignore. Built files, downloaded files, user-specific files, temp files, secrets, and non-production files. So even if we specifically tried to copy one, so if I said copy app settings.development.json into the current directory, this would do nothing because it's specified here in the Docker ignore. And I just realized I typoed that, so let's fix that. So now that we've got all our files copied into place, how might we run it? If we were on the command line, we would need to do a .NET restore to restore all of our NuGet packages. Then we would do a .NET build. Let's build in release mode. Then let's do .NET test, run all of our unit tests. We'll also do this in release mode so we don't end up with one release mode and one debug mode. Debug is the default here. And then .NET publish. We'll publish in release mode and we'll publish to the dist folder. .NET Publish is like the right-click publish inside of Visual Studio, but we're doing it here inside of a DevOps pipeline, inside of a Docker image. So this will be predictable every time. It's going to grab the DLLs, it'll grab the JavaScript and CSS files, and it's that stuff that we would want to send to our web server. So each of these are the CLI commands that we want to run to be able to do this. How would we do this inside of a Docker image? Well, let's run them. Let's run this one, and this one, and this one, and this one, and now they run as Docker commands. Now we do need to set some environment variables, and I'll just copy them into place because that's a little easier than watching me type. We want to set that environment variable to say we're in production, and we're going to set the URL to start on 80, and this plus says on all IP addresses. So don't just listen on localhost, but listen on all the IP addresses so that we'll get inbound traffic from our orchestrator. Then we'll add some metadata that says we're started on port 80. And what is the command that we'll start? We'll say .net site.dll. And that is in the dist folder. So let's work dir dist. And now we have a Docker file that could work in production. Now we could choose to deploy this today. It would work just fine. But we've broken some of the rules of Docker. And so let's see if we can fix stuff up. One of the rules of Docker images is that we don't want build tools in our image. If someone was able to pop our running container, they now have a compiler where they could put in some extra code and start to compile that code and then run it. So let's remove that compiler. Heading back to Docker Hub, we can see the ASP.NET repository. So let's pop that one open. And we have this base image right here. Here's the one that only includes the runtime for ASP.NET, but not the build tools. Scrolling down, we can see that there is also an Alpine version, so 6.0-Alpine. So back in our Docker file, let's split this in half. Let's say from this. Now, from here down is a different image than here. So we can say this is our production runtime server image, and I put server in air quotes because it's not a server, it's an image, but we can kind of think of it like a server. And here is our build server image. Cool. Now we've separated this into two different stages so that we can avoid getting our build tools and our source code into this production image and make that production image just ever so much smaller. We do need to fix up this. Let's set this to the app directory, and let's copy this, the dist folder into the current folder. Except for now, it's going to go look for a dist folder out here, and it's not going to find it. So let's say from equals build. Now this specifies the build stage. So let's name this one as build. And now this command will go copy the dist folder from here, from the build stage, from this stage. So we'll get only those built content. We won't even get our C# files into this new image. This new image is going to be really tiny. That's excellent. We just made our production runtime image much smaller. We removed that potential vulnerability by not having compile tools inside of our image. And so that'll work a lot better. Another thing that we can do here with this Docker file is that each of these commands will create a new Docker layer and cache it. So if we were to come in here into our JavaScript files and we were just to modify this one JavaScript file, that would invalidate this layer. And then rebuilding it, we would reinstall our NuGet packages. Now that probably takes some time, and if we haven't changed any dependencies, then reinstalling that on every build might be inefficient. So really what we want to do is restore our NuGet packages, then copy all the files, then build. Now we can take advantage of Docker caching. If I just change a JavaScript file or even a C# file, it will only invalidate this layer and it won't need to reinstall my NuGet packages. Now we do need to tell it where the NuGet packages are, so let's copy in our manifest, site.csproj, into the current directory. And that gives us the list of NuGet packages. In this case, we don't have any. And so now when we restore our NuGet packages, we know which packages to restore. Cool. So there's our Docker file. There's our configuration as code that tells us how to be able to build and then finally run our image inside of an orchestrator. We haven't told it anything about which orchestrator we're going to run in. We've just told it how to build this image. Any questions so far here on the Docker file?
questions.
Cool. Okay, so now that we've got that Docker file, we've got that configuration as code, let's build it. So I'm going to say Docker build, and I'll tag it as Docker in Azure and give it a dot. That dot says I want to build in the current directory. So, as I come in here and I say copy everything from that current directory, it now knows what directory that is. Okay, so let's build. Now it's going to do all of those steps inside that Docker file. If I need to, it'll download the base image. In this case, it already had it. And then it'll start to do those steps to be able to build up my image. So now it's doing a .NET restore. Yep, this is the slowest step. But it's pulling in all of those NuGet packages in a very deterministic way, so that if I do need to rebuild my image, I'll know that I've got the latest packages. Determining projects to restore. Here's the console output. I'm not sure why blue and black is the thing, but I'm glad the current command is white and then gray. So it looks like we restored our NuGet packages. Now we're going to build. I don't know, did we make any C# typos? Let's see. I think our build might succeed. Go, 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 go. Oh, there is a flag that we can pass. We can say no --no -restore, and it won't restore our NuGet packages, but it's pretty fast for it to notice that it already has them. It is taking a little bit longer than typical because I do have Teams running on my machine, and so it's a smidge more loaded than usual. But usually this kicks off in a few minutes, or rather a few seconds, like under a minute. All projects are up to date. So now we'll kick off the build. Go, 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 go. Part of the hard part about doing this demo is that sometimes I don't have internet access. Because I'm streaming, I definitely do. But this would definitely fail if I didn't have internet access. Build. Build. It succeeded. Woo! So let's run all of our tests. In this case, we don't have any unit tests, so we don't have any failing unit tests. Excellent. So it'll just take it a second to notice that. There's a way you can say --no -rebuild here, but it's really easy for it to notice that it's already built and just move on. Except, of course, my machine is overloaded, so it's going to take it 27 seconds. That's so silly. All projects are up to date. Does it need to build? No, it doesn't. Oh, now we're at .NET Publish. So now it's going to take those built resources, all the DLLs, the JavaScript files, the C# files, any images that I have, and package them up into that dist folder. I could then copy that dist folder into IIS or into another web server, and that would host my ASP.NET application. So again, I could pass in --no -rebuild or --no -restore, and then it wouldn't try to restore the things, but it's all good. The cool part is if any of these commands failed, the Docker build would fail and I wouldn't get a resulting image. So if I have a failing build or if I have a failing unit test, I won't end up with a final image, and therefore I can't break production if I have failing tests. That's cool. So now we're going to flip over to the other stage. And so we'll copy that content into place. And now we have that image that we can start to run. So yeah, I could definitely do a Docker scan to use Sneak. But let's say Docker run, and we'll map port 80 to port 80 in the container, and we'll run Docker in Azure. but maybe port 80 on my local machine is occupied. So I'm going to say port 8080. Now that I've got that image running, well, it'll take it a second to spin up. Now that I've got that image running as a container, I can come over here to localhost 8080, and I can view that website. There we go. Welcome. We just built an ASP.NET web app, and we containerized it. That's cool. So now I'm going to stop this app. Docker container list, Docker container rm, AB8E. I just need to specify a uniqueness to this, and so 4 letters ought to be unique. And now my container is no longer running. And so if I were to refresh this, now we get the site not found page. Similarly, if I wanted to start it multiple times, I could just run multiple Docker run commands, and now I have 2 copies of my web server running. Now that's cool. We were able to build and run our application as a container, but we don't have that orchestrator piece. We don't have that piece that is able to host it in a cloud hosting environment, monitor its health, automatically restart it. If our container crashed, we would need to rerun that Docker run command. So next, any questions thus far about the Docker file and Docker run processes?
Everybody's quiet, man. You must be doing a good job.
Either that or I'm muted.
No, I can hear you.
Cool. So our first stop inside of Azure is a Docker registry. Now we can definitely use Docker Hub. What we saw here was that it actually doesn't use Docker Hub for the Microsoft-based images. It's actually using mcr.microsoft.com. So they're using a private registry as well. And so we could use Docker Hub, or we could use a private registry. Now Docker Hub is awesome. You can get free hosting for public images. You can also get paid plans that allow you to do private images, or we could use Azure Container Registry. And the cool part about Azure Container Registry is that now the content is already in my subscription. So when I start up something, I don't need to pull it out of the cloud into this subscription. I'm not paying ingress or egress data charges. It is private only. There are tricks to be able to get it to host publicly, but it's kind of involved. So let's go spin up an Azure registry. I'm here inside of Azure, and I can create a new resource, and I can say container registry. Now, it's called Azure Container Registry, or ACR, but if you put Azure in the front or you search for ACR, it doesn't find it. Ugh. Yeah, search is hard. But I want to go create myself a container registry. So I come through and I'll pick a resource group. Let me create a new one, Boston Azure. And I'll enter a name, Rob Rich. I'll give it a spot where I want to put it. West US works. I can choose the standard or premium or basic. And it looks like Rob Rich is already used because, of course it is, I already have one. So going into my Azure Container Registry, we can see that I've got this registry. And if I go into access keys, it will give me the keys that I need to log into this registry. So my registry happens to be robrich.azurecr.io. So I'd come here to the command line and I would say docker login robrich.azurecr.io. And I've already done that. So now I can say docker build-t robrich.azurecr.io/docker in Azure v0.1. And the cool part is, oh, I have to give it my folder. Dot. The cool part is because this is cached, I haven't changed my Docker file, I haven't changed any of the build commands, then we can see that it just used the cached content and it was able to rebuild really quickly. That's cool. Now I have this robrich.azurecr.io/docker in Azure. So I can say docker push that to Azure. And I've already done that. So popping open this, I can come here to my repositories and I can see that we've got Docker in Azure and we've already got the v0.1 pushed up. Now I did it a little bit ago, but that's exactly what I did. Was I just did a Docker build and a Docker push, and that got it up to my Azure registry. Cool. So now that we have that image in our container registry, for all the rest of the demos, we'll just launch that image. And then because it's already in Azure, it's already in Azure. This is a private thing, so we may, for some of these, we do need to log in from the Azure service into our registry to be able to get that connection. But in this case, we've already got it. So Azure Container Registry, that was easy. We'll probably use Azure Container Registry no matter what other Docker Azure compute resource we use, because we really do want to keep those images private and we want to be able to pull them straight into our content. So next up, let's talk about how we choose cloud compute resources. You've probably seen this diagram. You've probably seen it so many times that you're annoyed. We're choosing what we're choosing to outsource. If we have an on-premise thing, we own all of it. If we choose infrastructure as a service, we can give up the servers, the virtualization, the storage, the networking. If we move over to platform as a service, we can give away more things. And if we choose software as a service, maybe like Salesforce.com or Azure Cognitive Services, we don't need to install anything. We just go to a website. So we have a machine on our system, an Azure VM, Azure Web Apps, and Azure Cognitive Services. Where do containers fit? Well, they kind of fit in between these two because we're owning a little bit of the OS, those shims that we need to be able to do that. We're owning our runtime, but we're not owning all of the OS. So it kind of fits in between these two. But there's lots of different places inside of Azure where we can choose to own more or less of our compute. And so that's usually what we'll be picking as we pick from the many places where we can host our containers inside of Azure. Now there's lots of different ways to run these apps. Azure Kubernetes Service, Azure Container Instance, Azure App Service, Azure Container Apps. We could even just install Docker on a bunch of VMs. And what we're choosing here is what we want to outsource. We're also choosing our orchestrator. So as we do these, all of these are real Docker. They're hosting real Docker images or OCI compliant images. We're not creating Microsoft brand Docker resources. We're actually using upstream content. So for example, when we run Kubernetes in Azure, we're running real live Kubernetes, not Microsoft brand Kubernetes. That's pretty cool. So for each item, we're going to take a look at what we're choosing to own, what we're choosing to outsource, some of the pros and cons of making those choices, and ultimately what scenarios might lead us to choose this scenario. Now, ultimately, we're going to ask which one is best. And the answer is, well, what scenario do you have? Let's find that scenario and find the Docker hosting platform that gets you there. Ultimately, what's best for your organization is probably different than what's best for my organization because we might have different needs or different concerns, or our app may be designed differently. So first up, Azure Container Service. And this one is definitely legacy. In fact, it's been deprecated for quite some time. So if you're on it, I'll be impressed. Azure Container Service was Azure's first mechanism into hosting containers. Basically, it was just ARM templates that would automatically provision virtual machines. You could choose which template you wanted to run, DCOS, Docker Swarm, or Kubernetes, and it would provision those resources and allow you to then manage those resources going forward. So I didn't need to set up Kubernetes. but I needed to own Kubernetes going forward. And if I wanted to horizontally scale to more nodes, I would need to pull in those virtual machines and hook them up to Kubernetes. So in time, we wanted a higher level of abstraction, and so Azure Container Service was deprecated. With Azure Container Service, we choose to outsource the provisioning and initial configuration, but that's all. Product updates, VM upgrades, Windows updates, node scaling, all of that is on us. It was retired some time ago, and so if you haven't moved off already, then here's where you might go. With DCOS, you can use Mesosphere's open source mechanism. With Docker Swarm, you can move to Docker Enterprise, which is now owned by, I've forgotten the name. And if you're using Kubernetes, then Azure Kubernetes Service is perfect. Oh, Docker Enterprise was bought by Mantis. So if you're on Azure Container Service, here's where you would move to. Next, let's talk about Service Fabric. Now, I put this air quotes legacy because the majority of Azure actually uses Service Fabric under the hood. A lot of it is moving towards Kubernetes, but Service Fabric is not going anywhere anytime soon. It's a little bit awkward to deal with, but Azure runs on Service Fabric. So if you run on Service Fabric, you are completely fine. But Service Fabric is kind of a wacky orchestrator. In this case, you don't create a cluster of machines. Azure automatically provisions a multi-tenant cluster for you. And so you just say, here's the content that I want to host, and Azure just hosts it inside that multi-tenant cluster. So the way to do it is I create a new Service Fabric project in Visual Studio, which just seems so weird. And then given that content, I can go into the Service Fabric Explorer and I can start to upload those services. Now, the cool part is I'm not limited to containers. I can upload platform as a service content, much like Azure Web Apps, or containers, or I think you can actually host virtual machines inside of Service Fabric as well. So Service Fabric is really good. All of the content of provisioning pieces is washed away. I just say, here's my app and run it. If you've ever used Fargate, it's not that different. So as Service Fabric, I've chosen to outsource the cluster management, the virtual machine updates, node scaling, container restarts, all of that is handed to someone else. And I choose to only own the container process. That's great. It's kind of the easy button. And so if you're after that easy button, then Azure Service Fabric can be perfect. I have a service, I just want to put it up in Azure, and it's great.
Somehow went on mute again.
I think we're lost here a little bit.
Thank you for calling me out for that. Sounds like my mic disconnected.
I think you're back. Sweet.
Awesome. Where did I get lost? Was I on this slide?
Yep.
Perfect. So Service Fabric is great if you don't want to take on the complexity of Kubernetes, but you do have multiple microservices that you want to host. It was originally designed for Windows, but you can do both Windows and Linux on Service Fabric now. So when would you choose that? If you want to hit that easy button, if you don't want to have to worry about Kubernetes management, and if you just want to say, hey, Azure, just run this. If you have Windows containers, you'll probably find an easier path on Service Fabric than on Kubernetes, but it's not impossible to run Windows containers on Kubernetes. So that was Service Fabric and Azure Container Instance. Next, we'll talk about Azure Kubernetes Service. Any questions thus far?
By a bunch. No comments. No questions.
Cool. So Azure Kubernetes Service is the big dog. It is the big service. It's the way to run Kubernetes inside of Azure. And the cool part is we're actually running real live Kubernetes. We're running upstream Kubernetes. This is not a Microsoft fork. This is actual Kubernetes. The cool part is that the control plane is completely managed for us. We don't need to pay for it at all. Google cloned that process, and so now the control plane is free on Google as well. You still pay for the control plane on AWS, but yeah, Azure started it. So because the control plane is a multi-tenant and completely managed process, we can't run anything there. But at the same time, we're now only responsible for the virtual machines that are our AKS nodes. So if we want to horizontally scale our nodes down to 1, then our cluster is pretty inexpensive. Or if we want to horizontally scale to more nodes, then we can take care of that, and we don't need to worry about the control plane at all. We just drag the slider to get more nodes. So let's go create an Azure Kubernetes service. Teams brought up the thing, and now I can't reach the other tabs in my thing. Okay, so let's go here. Portal.azure.com. So I'm here, and I'm going to create a new resource. And I would like Kubernetes. Kubernetes service, perfect. Yes, I would like to create one of these. I'll create a new resource group. Boston Azure. And now I can choose the scale of my cluster. So I'll choose dev test for now. What's my cluster name? Rob Rich. I can choose where I want my cluster to be. I can choose availability zones. In dev test, there aren't any. I can choose my Kubernetes version, 123.8 sounds good. I could get up to 124 if I wanted to. And I can also optimize for availability or optimize for cost. And in the dev test one, yeah, I'll definitely optimize for cost. I can choose the size of my node. And the cool part is you can choose node sizes later, but that's only to change one node. So this is kind of the last time you have to choose the size of your cluster. So in this case, I'll choose a D2 SV3. Select. I could swap particular nodes up and down, but I can't swap the node that it will automatically provision later. And so that's kind of a bummer. I can choose to manually scale or auto scale, and I can choose how many nodes I want to pick up to, you know, very ludicrous. In this case, I'll just choose one. Next, I can take a look at my pools. Virtual nodes is actually really elegant. It will automatically scale into Azure Container instances. That is amazing. We'll talk about that as we dig in some more. I can set up authentication. Networking, I can tell it to create a new network and specify the network details. A lot of traffic routing rules. You can see why Azure Service Fabric is kind of the easy button. Kubernetes is a bit involved. Similarly, the integrations, I can hook it to my Azure Container Registry. I can hook up container monitoring and Azure Policy. Advanced will give me nothing. And then finally, I can create it. But in this case, it's telling me that there's an error. Running final validation. I shouldn't have clicked that button because I wanted to go back to here and note that it's going to be an error on the name because this name is already taken because I happen to already have a Kubernetes cluster started here. So here's my Kubernetes service. And if you've ever tried to upgrade Kubernetes, you will really appreciate this. I can come in here to configuration. Nope, not this configuration, this configuration. And I can upgrade versions. So I'm definitely not going to do it in the middle of this demo, but you can just click here and have it automatically upgrade, or I've chosen to have it auto upgrade whenever a version is available inside my maintenance window. And so it'll always keep me on the current version. And that's really cool. So now that I've got a cluster created, let's start to run some stuff there. So I will do an AZ AKS get credentials. Then I specify the namespace or the name of the resource and the group of the resource, and then it will stuff things inside of my kubeconfig. So if I say kubectl get kubectl config get contexts, we can see that I have my Docker desktop context, but I also have my cluster inside of Azure. So I'll kubectl config use context Rob Rich, and now when I run kubectl commands, I'm actually running them on Azure instead of on Docker desktop. So I'm going to reach into my stash of interesting things and go grab this K8S folder. Save us a bit of typing of Kubernetes YAML. Kubernetes YAML can definitely get away from us. Here I have a service that will load balance across all of my resources. I have a deployment that specifies the details of how to start this pod. Notice here's my Docker in Azure v1. Oh, it's not v1 though. It's v0.1. So let me fix up that. Oh, here it is, v0.1. Specifying that image name and the container port. It's a little bit mad because I'm not specifying a resources limits. So I'll just give it an empty thing there. But here I've chosen to specifically launch only one, but I could choose to launch 3 or 10 or even have that automatically scale. So I've got my deployment now. I've got my service that will load balance across all of those pods. And then I have my ingress that will be able to map a specific host name. So here's that host name that I've chosen to point to that service. So the ingress maps HTTP host names into Kubernetes services. The service load balances across all the pods, and the deployment ensures those pods are running. So let's apply them. kubectl apply -f k8s/service. Now I could do this one at a time, or I can just say kubectl apply -f the entire folder, and it'll just loop through all of the YAML files in that folder and just push them up into Azure. kubectl get all, and we can see all of those resources that got created. Now, the unfortunate part about kubectl get all is it doesn't include ingress. So let's do all and ingress. And it will take a while for this ingress DNS to propagate, because not only does it need to propagate in Azure, it also needs to propagate up to the Azure, to the control servers, and then down to my ISP. So if we were to visit this URL right now, it probably wouldn't work. But we can see the pods running. So let's do this. kubectl port forward. And we could port forward into a pod or into a deployment. In this case, let's port forward into the service. Docker in Azure. And we could forward port 80 on my local machine to port 80 in the container, or in the service. In this case, I'm going to do port 8080 on my local machine. So now that I've got that proxy set up, I can come in here and I can say localhost 8080. And this website is running in Azure inside of Azure Container Service. Now that's awesome. I was able to start my website inside of Azure Kubernetes Service. And if I need to, I can come in here to my YAML, and I can specify how many copies I want to run. So right now I'm running 1. Let's run 2. So kubectl apply -f k8s, and apply is both an insert and an update. So it noticed that the ingress didn't change, the service didn't change, but the deployment did. So if I say kubectl get all, I now have 2 pods running instead of just 1. One started 9 seconds ago, one started 2 minutes ago. And just as easily as we created them, we can say kubectl delete -f k8s, and all of those things will get deleted from Azure. It's really easy to accidentally forget that you've got content hosted in Azure and let it go. So I'm going to specifically kill it as quickly as we can. So that was cool. We did Azure Kubernetes Service. Any questions so far on AKS? Cool. So what have I chosen to outsource with AKS? Well, I get to use full Kubernetes. So anything that will run in Kubernetes will work just fine inside of AKS. I can choose to own the Kubernetes version, or in my case, I chose to outsource that as well. I can choose to do node scaling, or I can outsource that as well. All of the container restarts, all of the node patching, all of the control plane is outsourced to Azure, and I don't need to worry about that at all. Azure Kubernetes Service, it is real live Kubernetes service. Windows is no longer in preview now, so you can use both Windows and Linux containers inside of AKS. Push button scaling, I love that. Just being able to drag that slider and get more VMs inside of my cluster, that is so cool. On the downside, Kubernetes and YAML. Now the Kubernetes YAML isn't always the easiest, but it is, regular normal Kubernetes, so that's just the way Kubernetes works. When would I choose this? If I have many microservices, then AKS is the perfect solution because I get to run all of them here in one place. I don't need to create a new Netlify account for each service or a new GitHub Actions, GitHub Pages account for each service or another Azure Web App subscription. I have all of my microservices in one place. I can use upstream open source Kubernetes, and it works out really well. Next up, let's take a look at Azure Container Instance. The cool thing about Azure Container Instance is it is a REST API for containers. Now, if I was to build a cloud architecture, I might have common nodes. I'd have a virtual machine mechanism. I'd have a storage mechanism like Azure Blobs, and I would have a mechanism for spinning up containers. And that is Azure Container Instance. Now, it's an API for spinning up containers. And so you can just say, hey, spin up this thing. But there isn't that orchestrator behind the scenes that will watch it and automatically restart it and scale it. And I actually learned that they did do automatic restarts now, but there's no concept of scaling. If I want to run 2 copies of it, I call the API twice. The cool part is it is completely utility billing. So if you've ever used AWS Fargate, this might feel right at home. It is per CPU memory second billed. So however many seconds it's running, that's how long you'll get billed. So it's perfect to be able to build an architecture on top of it. It's a great way to be able to run dev test utilities, but it's also great for, let's say you have a platform where you want each client to have a separate container. Then you could use this API inside your service to be able to build up your platform. So let's do some Azure Container Instance magic. Now I'm here inside the Azure CLI, and this command is wonderfully gnarly. AZ container create, I'm going to give it the name of the container that I want to create. I'm going to give it the resource group. My resource group just happens to be named Kubernetes. This has nothing to do with Kubernetes, but that's the name of my resource group. What's the image I'm going to pull? There's the Docker in Azure v0.1. I'll give it my username and password. I have those stored as environment variables. I'll specify the ports that I need, and the DNS label. So that's the DNS label that I've got. And then once it's done starting up, I want to go get the IP address. Well, the fully qualified domain name, the URL that I will use to be able to browse to this. Now, it does take a second to be able to spin this up in Azure, but what's really cool is that API is perfect for just being able to spin up containers really quickly. So let's go here. Let's go to HTTP that, and we've got our container up in Azure that fast. Now, DNS propagating may be a thing, so maybe we won't get it to load right away, but that's really cool. That is Azure Container Instance, just a really quick API for spinning these things up. So let's take a look at the containers that we've got. Container list, and we'll output as a table. In this case, I only have one, so we'll only see that one, but we can see it's running in this resource group, the Kubernetes resource group. It succeeded. Here's the image, the IP and ports that it's running. It's a public thing. Here's the CPU and memory that I chose. It's a Linux container, and it's running in EastUS because that's where my that's where I created this. Okay, so AZ container logs. Let's take a look at Rob Rich Docker in Azure. Resource group Kubernetes. And now that I'm taking a look at the logs for this, this is much like Docker logs or kubectl logs. Here's that console output that came out of that container. And just as easily as I created it, I can say AZ container delete. I'll give it my name of Rob Rich, my resource group. And I'm going to say yes, so that it won't prompt me to confirm it. And just as quickly as it spun up, it will spin down. And so there's it no longer existing again. Let's go take a look at our containers running, and we will see that there aren't any. Now that's really cool. We could also choose to spin up an Azure Container Instance here in the portal. We can say new Azure Container Instance. Or what's particularly awesome is if we go into our container registry and we go into the repositories and we pick a particular repository and then we pick a particular version, we can hit the 3 dots over here and we can say run instance. And it will automatically spin up that Azure Container Instance so that we can start to play with it and see how that works, which is really cool. So that was Azure Container Instance. Azure Container Instance is this really elegant API for building up containers. Now I've chosen to own spinning up those containers. So I choose to take on scaling and the container process. They do now have automatic restarts on unhealthy containers, but we used to need to own that as well. We've only chosen to outsource our host, our VM patching, our host infrastructure. Those are all outsourced now. We choose to own our orchestration process effectively. So when might I use this? Utility billing is amazing. If I just want to spin up this container real fast and see how it works, and I need a little bit more horsepower than on my local machine, then I can just push up a dev test thing, or I may choose to be able to build up a platform on this where I might have one client per container. So on the upside, it's utility billing, no infrastructure to manage. On the downside, there's no auto scale. So I would need to kick it off multiple times. I would need to keep track of my traffic and manually scale that. One con that used to be here that is no longer, I used to only get one port forwarded in. You can now forward in multiple ports into your Azure Container Instance containers. So when I choose this, when I just quickly want to spin up a test, or when I want to build a production platform on top of it. Now let me talk about virtual kubelet, we saw that checkbox about automatically scale into ACI. Virtual kubelet is that piece. For AKS, it is another node in the cluster. And the way it implements that node is by starting things inside of ACI. So this is a great way to be able to get infinite scale inside of our AKS and utility billing without needing to define our nodes. It's like one big giant node inside of ACI. It is so cool. On the upside, it's great to be able to scale into this infinite thing where I get utility billing. On the downside, I need to run the virtual kubelet somewhere, and I can't run it in the control plane. So I do need one node in my cluster, but I only need one, and I can push everything else to ACI. So that was Azure Container Instance, our API into containers. And we also talked about Azure Kubernetes Service. Next, let's talk about Azure Web App Service or Azure Web Apps. Now, the cool thing about Azure Web Apps is it's kind of platform as a service. It's a really great analog to IIS. If you squint real hard, it's like, well, it's exactly IIS. And so it's exactly IIS, but it also runs containers. Now, it only runs a single container, so this is great for a monolith. If you have many containers, then you would end up with many Azure App Services, and maybe that's less effective. You might want to choose Kubernetes. But it works with both Windows and Linux containers, and like IIS, it automatically restarts. So I can come in here and I can say, I would like to create a new Azure Web App, and app service. I think app service domain is the right one. I may need to say web app. Yes. Oh, this is an app service domain. Let's try again. I have some app services. So inside here, let me say I would like to create a new one. And after I give it an app name, I can tell it that I'm running code, which is probably what we've done before, or I can make it a static web app, in which case it'll run on Azure Storage, or I can say it's a Docker container. Once I say Docker container, now I can choose my container OS, and I can pick my registry. Now it's a little bit mad because I haven't given it a resource group or an app name yet, but once I get to the Docker settings, now here it's saying a single container. Oh, we've got Docker Compose now. And I can point it at my container registry, and then I can pick a particular image and the tag. And the cool part is if I choose latest, it will actually create a webhook that automatically will update my web app anytime I update my container. Another way to create these app services, if I come into my container registry, I can actually go into repositories, and I can choose a particular repository and version. And I can also say, oh, I went a little bit too far. Right-clicking on this version, I can say deploy to web app, and it will automatically create that webhook in case I update latest to automatically redeploy that app. And so what we saw here when we were looking at app services is that there is a site called Rob Rich, and until decently recently, my website ran as an image inside of Azure Web Apps. It now runs in Azure Storage, which is quite a bit easier to update and refresh because it's pretty big. But yeah, it just had a webhook that anytime I pushed an image up to Azure Web Apps or Azure Container Registry, it would automatically update my application running here in Azure. So that was Azure App Service. What's really cool is I've chosen to own the container process, but everything else we've chosen to outsource. Container health and restarts, container scaling, host infrastructure, VM patching. We could even do auto scale, much like we would with any other Azure web app. On the upside, Azure manages everything and it just runs our container. We don't need to worry about how do I hook up the Kubernetes things, how do I, do all the things. On the downside, it only runs a single container and only a single port. So if I need multiple ports going into my container, then I may need to flip over to Azure Container Instance or probably Azure Kubernetes Service. So when would I use this? If I have a monolith that I'm just trying to lift and shift and I want to get it into a container running in the cloud, then Azure App Service is perfect because I don't need to futz with a lot of stuff and I get that interface that is probably really similar to IaaS that I'm already familiar with. Now, there are less options available inside Azure Container Apps or Azure App Service when I choose a container because some things are managed by the service. So I can still inject in environment variables, but I can't, for example, pick the platform as a service architecture. That's baked into the container. So next up, we could choose to install Docker in virtual machines, and this is definitely the ninja move. But if you want complete control over everything, then you can install whatever you want in a virtual machine. So we might choose to install Docker or Kubernetes. Now, in this case, we would provision some virtual machines. We would install our orchestrator of choice. At this point, we manage everything. Now, this might be perfect if you're doing a process that needs to run across clouds and you want to have an identical version of Kubernetes in every cloud. So now you're not dependent on when the cloud chooses to upgrade to the next version of Kubernetes. You can take control of that. So we've chosen to outsource, well, buying hardware? That's pretty much it. The majority of the content is now on us. We've installed Kubernetes. We choose to manage and patch it whenever we need to or not. We need to worry about container health and cluster patching and scaling. We own everything. Now, if you choose this path, that's probably exactly what you want. But, well, that's what you get. On the upside, you can control everything. On the downside, you must control everything. So when might you use this? If you're building a software as a service platform and you need to go across clouds and you need all of them to be exactly identical, then you managing everything might be the perfect solution. So we looked at lots of places where you can run Docker in Azure. And so kind of scaling them from most managed to least managed. On the least managed side, we have VMs and then AKS, ACI, Service Fabric, and finally App Service is the most managed. So whatever our comfort level on the management scale might lead us to choose a solution. Similarly, how many containers can we run? If we only have a few containers, like 1 or 2, Azure App Service can be perfect. Azure Container Instance and Dev and Test can be great because I can just scale them up when I need it and then kill them off really quickly. Service Fabric and AKS can run lots of images. And VMs can run as many images as we want, but we're paying for the VMs, so the scaling steps are pretty intense. By comparison, if we want to build our own orchestrator on top of Azure Container Instance, then we get utility billing and we can scale to the scale of Azure, which is phenomenally big. A similar scale. Oh, so this kind of combines all of the different details of all of the different Azure compute resources that we've got. You can grab these slides from robrich.org, or here's the money shot, where we take a look at each of those services. They all run Windows and Linux. We can take a look at their pricing models, auto scale models, auto restart models, and whether we choose to own the virtual machines that they run on. Any questions so far about Docker in Azure?
No questions.
Awesome. Hopefully that gave you a minute to snap a picture if you wanted to as well. So what's really cool here is that we've seen lots of places that containers will run inside of Azure. We didn't mention Azure Container Apps, which is brand new. It's kind of half Kubernetes, but kind of a little bit simpler. It includes Dapper, which is really cool. But ultimately what we saw is that there's lots of options here. Now the question isn't so much which one should I choose, but rather which one best fits my use case. And what's really cool is that Docker will meet you where you are. So wherever you are, whatever things you need, you can plug in exactly that way. Do you want to own everything? Then Azure VMs would be perfect. Do you want to own nothing? Then Azure Web Apps might be perfect. Do you really like open source? Then AKS to be able to get built-in Kubernetes might be perfect. Or do you have a few things that you want to just spin up really quickly and then discard? Azure Container Instance might be perfect. Ultimately, Azure will meet you where you need to be. This was a lot of fun getting to show you choosing from the many ways to Docker in Azure. The slides are up online right now at robrich.org, and you can hit me up on Twitter if you're watching this on demand at rob_rich. For those of us here live at the event, what are your thoughts? What are your questions? What other things should we mention next time we do this talk?
So we actually have one question right now. It is from James, and he is asking, are you familiar with ACA, like serverless Kubernetes? It was GA'd in May.
Yes, Azure Container Apps. The cool part about Azure Container Apps is it is a simpler YAML than Kubernetes YAML, but it really tries to reach that Kubernetes-like audience, the people who are just kind of overwhelmed by Kubernetes YAML. It is kind of the gateway drug because pretty soon you may hit those limits where they've made opinions that you may not agree with, or they've blocked, in the name of simplicity, they've locked you out of some of the Kubernetes things. It does run on top of Kubernetes, which is really awesome, but it doesn't quite feel like Kubernetes. So it is a fun thing to play with, but every time I get into it, because I'm familiar with Kubernetes, I'm like, no, I'm just going to upgrade to the real thing. What's your experience with ACA?
I think James doesn't have a mic, so he's gonna type his answer.
That works.
Oh, okay. So he's saying he is using it for a couple of projects.
Oh, excellent. I'm glad you found success.
Porting real Kubernetes to Azure ACA. Okay, that's good.
Ah, how interesting. I usually go the other way. It sounds like we may need to find ourselves around a beverage where you can tell me more. This is cool.
Yeah, you guys should connect. Okay, I don't see any other questions. Whoever has a question or a couple of questions, feel free to unmute yourself. Okay, I guess that's it. No more questions.
Awesome. Well, this was a lot of fun getting to present today. Thanks for having me here at Boston Azure.
Thank you so much, Rob. Thanks everyone for coming today.
What's up for next month?
Ooh, we're still figuring it out. That will notify people once we finalize the schedule. And everyone, please keep following us on Twitter and check in Meetup group. Yeah, we'll be posting there.
Sounds great. See everyone next month.
See you. Thanks, Rob.
Are you still there, Rob? Are you still there, Rob? When you had the website up, I tried to go to that site and it looked like I couldn't get to it. Is that because it wasn't available to all?
Looks like he is gone. Which site are you referring to?
When he created that site out on Azure, I actually tried to go to that site and it didn't hit it. So
which demo was that?
it was one about 3/4 the way. It was the
Was it-
Docker in Azure East US Azure Container IO.
Yeah, I'm not sure. He may have pulled the plug on it quick enough, or it was one of the demos that wouldn't have had a public endpoint unless you added something additionally to it.
Yeah. All right. Well, that's all.
I'll have to watch the demo again and see if I can find it.
All right. Well, I know he took it down, so it's not there now. All
That's
right.
cool. All right.
Thanks.
Have a good
Bye.
night. Bye. Duty. In the